Okay, so now I added the logic to find out the closest ladder for the NPC. Now let's implement a functionality to climb down this ladder. Right, so what I'm gonna do is I'm gonna go to actually climb down or climb up. Okay, right. So what I'm gonna do is I'm gonna go to this behavior tree and let's implement a new task called BTT climb ladder. Simple as that. It can be either climb up or climb down. Anyway, it will be the task. Right. So at this task, what I'm gonna do is at event receive execute AI, and I will promote this one into a variable, and then I can simply call the interact BPI function call to this pawn. Because if you remember at the character base, I have implemented that interface called BPI interact. So whenever I call this interface function, it will simply start interacting with the ladder. Okay, so that's the benefit of having these sort of interfaces, so that you can easily call those functionalities at the appropriate places. Right, so once interacted, we have to start climb up or down, but yeah, let's just first test this thing. So I'm gonna add the climb ladder after here, and let's try to play and see. Yes, now you can see these guys interacted with the ladder and they entered to the ladder from the top, and you can see this character is also interacted with the ladder and she is interacted from the bottom. Right, then the next thing is, once this interaction is finished, or let's just say once the character has been entered to the ladder, he start climbing it, which means we need to add the event listener. So at the pawn, let me get the ladder system component reference, save it as ladder system, and then the ladder system I'll call, let's just say what on enter ladder, and I'll create a matching event call on enter ladder, and just for the time being I'm gonna simply print the ladder reference so that I know this event is being triggered. Right, now let's just see on enter ladder. It is not being printed. Maybe just a hello world string. Nope. Why was that? Because this interaction will be called at the character and it will call the interact, and it will perform these interactions. So we don't need this anymore, so I'm going to delete those stuff, and it will call the enter ladder, and once everything is finished the character will be moved to, and also it will call the enter ladder. This one should get called. Maybe let me add a print string here, just say here. Yeah, you can see it is printing here, which means this event is being called. So it should be able to listen at here. Maybe let me add a sequence and try to connect it like this. I'm not quite sure. Maybe there could be a race condition. And let's play and see. Right, now it prints hello. Yes, it's a race condition actually. This function is getting called before the registration. So we need to first register the listeners, then only we should call the function. Then it will get triggered. Right. Now at the on enter ladder, we should start climbing based on the enter transition state which has been saved. So how do I figure out the saved ladder state? Oh, the enter transition state. But maybe what I can do is, let's go back to the, so now we have a lot of nodes. Let me close the unnecessary stuffs. Right. Now at the ladder system, yeah, here I suppose we need to explicitly say what's the entering, right? What I can do is maybe at here at the on enter ladder, let me pass the e ladder enter transition state. So this is ladder enter transition state, and at the entering I'll pass the enter transition state like this. Okay, and similarly for the exit ladder also I will pass exit transition state, which is ladder exit transition state. Now if I compile, there will be some errors. Let me refresh it, and let's pass exit transition state to there, and here also. Right, also refresh the node, connect it. Right, now if I go to the NPCI system, that will also be break. So what I can do is, here I need to add enter transition state with the same name. So I can copy this name from here and add it to here, compile. Now that error is been gone. And similarly for the exit, I need to add the exit transition state, and let's copy the name from here, paste it to here, compile. That error has been gone also. Right, now at the climb ladder, if I compile it, again there is that error. So at the enter ladder, let me add the enter transition state again, and the name should be this one, paste it here, compile. Now that error has been also gone. So make sure these names and types are matching, and also the order of parameters are matching. Otherwise these signatures may not match properly and this one will fail. Right, now everything is good to go. Then what I have to do is, now I know what's the latest transition state is. Then what I can do is, maybe let's promote into a variable called cached ladder enter transition state, and then based on the enter transition state we should control the movement, right? So again, the movement can be influenced. If you check out the character based, we have an interface function called bpi move. So we just simply need to call this interface function with the corresponding axis value, so it will be automatically start to move the character on the ladder, because within the character itself it will evaluate which type of a movement that we need, and if the character is on the ladder it will climb, otherwise it will move on the ground, right? So we don't need to worry about that functionality, we just need to call the appropriate function at the task. Right, so at the climb ladder, what I'm gonna do is I will take the pawn and I'll call the bpi, I will call the bpi move function like this. And let's split the struct, and I'll mark the is pressed as true. And we don't need to worry about the x-axis because that's the horizontal axis. So since the ladders are vertical, we need to simply control this value. So this value will be dominated based on the transition state. So I can simply pass the transition state as the select index, and here we have three options. If it is none, simply the axis value is 0. If it is climb on top, then the axis value should be -1, because if the character climb from top, then he has to move down, which means the axis value is -1. And if it is climb on bottom, he had to climb up the ladder, so it will be 1. Simple as that. Okay, and so the next issue is actually we need to call this one for each tick, because this function will be called only once. That means this will triggered only once, I suppose. But anyway, let's just test that out. So I'm gonna play it. Right, so there is error. Maybe let's go to the player base, try to compile. These functions also fail because we change its signature, right? So at the on enter ladder, I think now we need to add two stuffs. The first one is ladder reference. Okay, and the second one is enter transition state. Okay, one error has been gone. And this function, this is exit, so we need to add ladder base reference, which is ladder, and this one is exit transition state. You can copy it from here, compile, save. Right, now let's play. Okay, the character has been able to enter the ladder, and it will move down only one step, right? Because that function is not getting called again and again. So what I can do is at the ptt climb ladder, let's call event receive tick ki, and And what else? Right, I'll create another boolean called can move, and by default can move is false, but here if we enter the ladder and if I says we can move, then the can move will become true only if this one is not equal to none. Right, and then at the tick AI, if I can move, instead of calling it over here, let's just cut and paste here. If I can move, I will be moved. So here if it is equal, then I can't move. Compile, save. And also I'll take event listener on exit ladder and create a event with a matching event. Call this one as on exit ladder, and maybe I can call it over here. And at the on exit ladder, the can move will become false, so that it can't move anymore. Right, now let's test that out. They are climbing and climbing down continuously, right? And this guy is climbing up because that character climbed from the bottom. Let's wait until they finish their climb. Right, exit from the ladder also true. Right, everything works as intended. Now let's wait this guy also finish the ladder climb. Okay, she also have been able to exit on the top. Right, now everything works fine. The remaining part is maybe I need to somewhat randomize the what do you call the NPC movements, right? Or the AI behaviors. So we can do that simply. Let's just say that the NPC AI system, when the character is exit on the ladder, I'll explicitly change the AI behavior back to roam, right? And then we can wait some random time. So maybe I will pick some random floating range. Let's just say after some random time within 3 to 5 seconds range, it will again reset the AI behavior back to climb ladder, right? And by default I will set the AI behavior as roam, like this. Okay, and yeah, maybe let's promote this into a function called, no, we can't promote into a function because it has a delay. Maybe let's promote into a, or maybe let's create a custom event called randomize AI behavior. I'm gonna simply plug it to here. And I'll call randomize AI behavior at here. And also at the begin play, I will call it like this. add a sequence, then call. Compile, save all. Right, now let's check. So by default now they are roaming for some random time. Then after that they will pick up the ladder location. Then they move it to there. Then some of them are climbing up, some of them are climbing down. And let's wait. They finish their interaction. Okay, they exit from the ladder. Then they roam for some random time. And after that they will pick up another ladder and climb it there. Okay, everything works pretty much fine, but some of them can remain on this idle state if there are some race conditions. So what we can do is maybe the acquiring part can be changed, or else let me add some weight here. Let's just say maybe 1 second with 0.5 dilate offset, and here the closest ladder we are acquiring, I'll simply disable it for the time being because the acquiring part is dominated by the entering. Okay, yes, they have been able to pick the ladder, but some of them are not actually rotating to the location. The issue is actually the tracing. So this guy will perform a enter trace, but since he is facing on this direction, he can't enter the ladder. So only if he face this direction, he can enter the ladder, because that's when the trace interact, right? So I just disable this one from here. I can remove it because it will be dominated by the entering. So how can I fix the trace? The easiest solution would be, let me go to the ladder system and I'll enable the debug trace, and let's check the interact trace for ladder. Right, this one, this radius is the problem, right? So you can see I have 50 radius right now, but let's just make it as 100 maybe. So we will have a much more massive range. So now I can find out the closest ladder like that. Right. So the characters will overlap actually. That's totally fine, because in many games, if the characters are there, so it will be overlap like that. So that's totally fine. But mainly you can see all of them are able to interact with the ladders properly now. Right, and you can see this guy find out this ladder and he's climbing that and he's climbing that. Yeah, everything works properly. Also, you can see the traces happening on runtime, so that you can debug those stuff as well. Right, so I think that's it, and we have a pretty good setup. But before winding up, I think we need few things to be fixed. The first one is that I think, actually not fixed, but to be refactored a little bit. So if you check out the level manager, I think I added some print strings to there. Yeah, so at the acquire ladder, I'm printing this one. So I will print it only when I enable the debug. Okay, So let's just say debug ladder availability. This goes to setup bug, and only if this one is true, then only we are printing this string, which is for debug. Alright, so likewise, let's check other print string statements across the system. Okay, these are default stuff. So the level manager, I have this print string which is being type guarded by this debug boolean, which is correct. Then I have another one here. Well, these are fine because these are like manager level specific print strings, so they should not be disabled by debug. Yeah, I think that's also good. So make sure before packaging your system or before packaging your project, you have been correctly restricted those print strings as well, right? Right. Then finally I can disable the debug for the ladder system as well, because I just enable it just to see this interaction sphere trace. Okay, right, now everything is being disabled and let's play. So this is the production ready code, but yes, still we have this debug trace is being printed here, because here at the get closest ladder I enable the debug as true. So let me make it false, so it will be okay. Play it. Right, everything is good to go. Also, let me verify the frame rate as well, because I care about the performance. So you can see everything is running on almost around 110 FPS, which is pretty much good. And yes, everything is really great. The frame rate is not dropping, and NPCs are not blocked or not conflicted with the ladders. And yes, everything works pretty much fine. But here you can see now this guy is being blocked because they're trying to find out the same ladder. So what I can do is, I think at the closest ladder we shouldn't remove that acquirability check. So at the closest free ladder task, let's just get the level manager and acquire it here, because otherwise it may stuck with some race condition. Right, now let's test. Okay, they are interacting. Climb down, climb up, everything works. And one other thing, if you want to perform climb up fast or slide, you can add that to the action as well, because we have that BTT climb ladder task. So maybe you can add some randomizations to perform a specific interaction to either climb up fast or slide down. So that's a very simple scenario. Maybe you can try that out. But I think functionality wise, this is the best thing that we can have, right? So you can see now those characters didn't stuck on the same ladder. They always find a unique available ladder, and right, everything works pretty much fine. Okay, so I think that's it for the ladder system, and we have covered a lot actually. We started from the procedural ladders, and then we implemented the customizable ladder actor. Then we talk about ladder interactions. So there we have seen how to enter and exit from the ladder. And then we talked about ladder movements. So implemented very sophisticated animation blueprint with states and state transitions. And finally, at the last section, we implemented this NPC AI interactions on the ladder, so that not only the players but also the NPC actors are being able to interact with the ladders. Right, so that's about the ladder system, and I think this is the last tutorial. But later on, if you find out any bugs to be fixed, or maybe if you request new features to be added, let me know those stuff. You can just share those information on the Q&A section. So I'll go through those stuff, and maybe I will create some new content afterwards as well. But for the time being, this is the end of the course, and I'll see you there. Thank you.